Good evening, Mr. Prakash Rao, sir, students, and our colleague, Mr. Maniraj and Ramesh Kannan. I am Sadiq Basha, Admin and Accounts Manager in Puthiya Thalaimurai Foundation. I am really happy to invite you all and meet this Zoom session. Dear students, today our chief guest, Mr. Prakash Rao, is retired outstanding scientist in ISRO. He was serving as director in headquarters Bengaluru and reporting to chairman. Also served project director GSAT 9, 17 and 18 communication satellites. He is MTech in electronic instrumentation postgraduate and 37 years experience in ISRO. He is a chairman of project monitoring committee for 75 students satellite mission announced by the Prime Minister of India as part of Azadi Ka Amrit Mahotsav. Dear students, our chief guest got merit award in recognition of his meritorious contribution to Indian space program and is a National Governing Council member of ISSC, that is Indian Society for Systems Engineering. He served as Executive Committee member of Astronomical Society of India for 2 terms. Considering his significant contributions, he is admitted as a Fellow of the Astronautical Society of India. Dear students, today our colleague role is Mr. Maniraj's interaction with the students and Mr. Ramesh Kannan role is vote of thanks. Now we will invite to our chief guest, main speaker, Mr. Prakash Rao, sir. Sir, over to Mr. Prakash, sir.
Yeah, good evening, everyone.
Good evening, sir. Yeah.
Is my screen fully visible?
Yes, sir. Yes, sir.
Okay. I am going to talk about the career opportunities. First of all, I would like to. Has the slide changed?
Yes, sir. First slide is sir.
I am very happy to be with. Is it there?
Yes, yes, sir. Sure, sir.
Okay. Okay.
Yeah,
So
visible,
I
sir.
would like to, before I go ahead with my presentation, I appreciate the
Yeah.
interest of the students, whoever are attending, to join the space fraternity. Please note that I am not just saying ISRO, it is the space industry rather, a very challenging and fulfilling sector. And I would like to place on record my appreciation for the alumni of the university for a very good initiative which they have taken. And hearty congratulations to Sri Venkatagiri, who is a CEO of Explore Space and Global Trade Driver. He has a lot of zeal to spread the space activities and bring various stakeholders onto a platform. And I also wish him all the best for his vision to take a fruitful shape. I think students, you all would have read during your childhood one poem. I don't know. I keep 6 honest serving men. They taught me all I knew. They are what and where and why and how and who. Like that, the poem goes. So, what it essentially says is if you want to learn about anything, you have to ask these fundamental questions. What is it? Why? How? Where? Like that. Some 6 questions are there, like that. So, my talk also, obviously, in a short span, we cannot be covering everything, but it will give you a brief idea and overview of the opportunities which are available. So instead of straight away going to carry like that, I thought I'll talk a little bit about what is space, why we have to explore space, what are the applications for common man, and how ISRO has started. So the ISRO Indian Space Program has started with the vision of Dr. Vikram Sarabhai, who told that we must be second to none in the applications of advanced technologies to the real problems of man and society. So at that time when it started, it was mainly with the intention of solving the day-to-day problems of common man and be helpful to the society. Okay, today we have become more prosperous, we are having more money, so we can explore space. That's how Chandrayaan and all are there, which are having a long-term applications also. So before I go further, I will first try to explain very briefly why space we have to go. In space, going to space means what? You are going to higher and higher heights, correct? See, the low Earth orbit satellite, it will be around 400 kilometers. A geosynchronous orbit will be around 36,000 kilometers, like that from the Earth's surface. So we are going up and up and trying to see. Why you have to go to height? Because the larger coverage area. If you see any forts, you see any fort, there will be a watchtowers. Why? Because from height you can watch all around the city, who is coming, who is going, everything can be watched. Same way, lighthouses, you are anyway in Chennai, so you know lighthouse and all wherever they are there. There also that will be on a height. And movie Bahubali also, if you see, when he has to destroy a large number of soldiers, he goes to a height and from there some cloth he will spread on that, some fire or whatever the ammunition, and then they will try to spread. So that is the advantage. Obstacle free, of course. See, nowadays the earlier video means marriages and all. People, photographer used to be at the center. He used to push aside people and all that. But now drones have come to cover. By what is the advantage of drone? Again, it's going to a height and seeing the full coverage. So there is no obstacles. So nobody will be disturbing your view and unaffected by natural disasters. See, floods or earthquakes and all such things when they happen, if the government wants to know what happened, viewing from space is the best option because otherwise, even to you may not be able to approach also those places and not restricted by borders. So strategically also, if you want to observe, no more need for James Bond like people, except for very few. But otherwise, we can see what is happening elsewhere, where we do not have direct access. Also, you can see, and privacy and security. Any asset that is there on ground is always prone for attack. But in space, it is much secure. There are ways to kill, okay, but that can be done only by a big country, not a person with one rifle or a small group of 10 people cannot come and attack. Okay, so that is the advantage of going to heights. And most important is the repeativity. If you want to see the same thing, suppose borders you are observing or a crop you are observing, every day you are seeing that some disease is there or something has happened. Now you have sprayed some pesticide or whatever, you want to see how it is developing all over India. If you want to see, aerial means or physical ground means is very tough. So in from spacecraft, if you take a photograph, all of India can be covered or a very good area can be covered. That is the advantage, and flexibility and expandability. If you want to have more, you can always add. But there are disadvantages, of course. When you go to higher height, you will be seeing the detail in a smaller way. So the resolution will suffer. Or if you are hearing something, the volume signal will come down. Okay. And unwanted signal, along with the wanted, there will be so much unwanted thing will be coming. And the environmental effects. Space itself, I'll talk about it, has a very harsh environment. And of course, cost, because you have to make things to work like that. So it will become costlier. But when you compare it with a satellite in geo's orbit will work for 15 years. 15 years, whatever benefits you get out of it, same thing you try to do it by some other means and compare the cost. Space is definitely a very attractive option. Not only that, and some places you cannot go also. So all that will be done only by going to the space. So now I'll tell about very fast about the applications. Space for communications, when you take, again, wide coverage is the advantage. Broadcast to mobile stations like air, ship and all, if you want to communicate. By terrestrial means it is not possible. No? If a ship is moving or Cargill like places you take, where it's not possible, no terrestrial link is there, towers may not be there. So there, mobile to mobile communication, if you want, through spacecraft will act like a relay and it should be possible. And the distance independent links, whatever be the distance, it is not going to bother when you are doing it with space. Reliable and privacy, all other things I have told. Of course, other small disadvantages will be there. They have to be overcome by use of technologies. That is where the role is there for people in space industry to make all these challenges you have to overcome and how to put a beautiful bird in the space. Same way for remote sensing, you can observe a large areas. Stereo coverage is possible only when you go to a height. By sitting on ground, you cannot have stereo coverage. So revisit and relook capabilities I have told already, and high resolution and not falling within our control you can view, and observation of land, sea, everything is possible from space. So there are again resolutions, limitations which have to be overcome by technology and development and research and developments. Other applications, all of you know GPS. GPS is nothing but a global positioning system. There series of satellites are there which are giving the signal, and India has its own NAVIC. Like that, GLONASS is there for Russians. Like that, different constellations are there. And meteorology and disaster warning, space is the only solution. You get every half an hour the whole world what is happening, the weather picture, correct? Every half an hour you are able to see such a fast coverage. It is possible only by going to space. And disaster warning, earlier if you see any big cyclone like Divisima and all, when they happened when I was younger, tens of thousands of people died. Okay. But recent Hudud, how many people died? Some five or six, maybe. That also because they were not ready to vacate their own place and they were not ready to move. So that is the other advantage. Disaster warnings and all, it will help. And space science, of course, now with Chandrayaan and Aditya, planetary exploration and space science, now everybody knows. And here the main advantage is why you have to go to space for seeing even Aditya. On ground, you cannot see the full wavelength. You will see only visible and radio waves. But beyond that, if you want to go to the full electromagnetic spectrum that is coming from sun, want to explore X-ray emissions from sun or gamma rays or any other band, it is possible only by going to the space. Okay. Apart from the observation is also free of atmospheric effects. On ground, you will see stars twinkling because it is getting absorbed. But if you go to space, you need not be seeing that twinkling. So, what is a space system? When you talk about space system, actually, what does it mean? So, there are three segments to the space system. One is the transport segment, that is the rockets, which are most attractive, glamorous. Okay, that is what everybody wants to join space because of rocket, correct? Because it's very attractive. Even Shivakashi rockets, in our childhood also, when we were firing crackers, the most attractive option was rockets, correct? So this is the transport segment. The purpose of rocket is to take the spacecraft to the desired height and leave it there. So it job ends within few minutes or 1 hour. Like other day Aditya was 1 hour, or some proton missions and all may take 8 9 hours. But it will be short-lived mission, but it has to work perfectly. Then the real space segment, from where you have all the applications to do that, what we call as payload. It could be a remote sensing camera, it could be a communication transponder, or it could be a for your meteorology, whatever scientific instruments are there. So like this, various instruments which are doing the required experiment or observation, they are called payloads. Okay. So the space segment will be consisting of the actual satellite along with the payload. Okay, and the ground segment, because both rockets and satellites have to be controlled and monitored as they are going, what is happening. And especially spacecraft, I will come to that. And the network, you have to receive signals from the ground, whatever application you are there, that some data will come. Or even Tata Sky itself, you take application from satellite, signal is directly coming here, the program. From your own dish on your house, you are able to receive. So the network is there to receive, and then you have a set top box on the ground. So these are the ground segment, correct? So these are the three segments of the space. Before, I just wanted to, because people also were interested to know what kind of attitude you should have, no? Or after you join also, what kind of. I'll just give you an example. Here you can see that whatever you are seeing here is an Antonov cargo aircraft. What is there is one metro coach is coming inside this. Actually, they make the metro coaches also while doing, they will fit it to fit. The sizing is done such that it will not exceed the size of these aircrafts, because there are very few cargo aircrafts like this in the world. Okay, and in recent Ukraine war also, two of the aircrafts were lost. Okay, so then the here our spacecrafts also are transported. You can see here in a container. Okay, and then transported to, suppose we want to launch from Arianespace, French Guiana near Brazil. So we will pack our satellite inside a container. Here also you can see another satellite or something else shipping containers, and this is inside of the aircraft. Okay, what it looks like, but it's basically for taking the cargo, not for human beings, except that the pilot and the loaders, unloaders, and the customer side, whoever is carrying, if they want, like spacecraft, we will never leave it alone to them. So one or two people from ISRO or whichever space agency will be traveling along with the spacecraft. So for, except for them, it is not required. So what is special about cargo is it will not be having pressurized cabins. Like passenger aircraft, in cabin pressure, when it comes down, oxygen mask will fall. So all those things we know. Cargo aircraft don't have all those luxuries, except for the small area where the pilots are there and the some loaders, unloaders like that. So this year I'm showing you what happened to one of the satellites. We went to Guru for launch. There, after a month after we went, we were ready, we unloaded and started testing our satellite. Because the Ariane rocket can lift very heavy weights, it needs 10,000 kg. Our satellite was only 4,000 kg. So, along with us, another 6,000 kg satellite of Japan was also supposed to fly. So, they came after 2 3 days after we have gone, and they came, and when they removed the top cover, their spacecraft container was in this shape. It is not actual container. I'm just telling, previously you have seen the containers. So it was in like a shape like this. It has become like an hourglass, no? Sand glass will be there. So like that it has become shape. Why? Because whenever an aircraft, cargo aircraft goes up and down, it experiences pressure difference between inside and outside. So due to the difference, the pressure difference, even if you drop from a top of a mountain one water bottle, okay, by removing water and just cap, it will shape will change because of the pressure difference. Here what happened? It like that. But then all people are transporting. Why it should not happen to all the containers? Here what happened is normally we have something called breather valves. They will be at the bottom, at all corners or in the middle also. They will be opening and closing depending on the requirement. Where how the to equalize the pressure both inside and outside. Here for some reason they have not worked. That they found out, I think, though it is not official. What might have happened is when they were transporting this aircraft to from their rocket center, satellite center to the airport, they didn't want anyone to see that container or whatever, so they tied it up with a tarpaulin. That tarpaulin they tied so tight, these breather valves were not able to breathe. You have put valves, but you have closed it by wrapping with tarpaulin. So actually, before loading into the aircraft, they should have removed the tarpaulin. It was not originally planned. They have done some last minute change. In space, we have one saying also, last minute untested improvements will lead to 100% failure. So here like that, they did something. Okay. So here what I am trying to tell is just a simple act of not removing the tarpaulin before loading because it was not in detail or whatever it is. What happened is because of this, their spacecraft got damaged. To know whether it got damaged or not, you cannot just like that remove, no, because inside it can break. So they have to drill holes. Where to drill holes to decide it took 2 days. Afterwards, they drilled holes, sent some cameras inside, put some light, and then see. And they came to the conclusion that inside satellite reflectors have gone bad, and they have to repair them. To go back and repair and all, they took 2.5 years. They anyway their mistake, so they have to pay for it. But we were supposed to go along with them. Because our co-passenger is not there, we also had to wait. Of course, we didn't wait 2.5 years. Ariane has got a very good launch manifesto. So what they will do is some other next one in the list, but we have to wait 2.5 months for the next satellite to come. Okay. So what I am trying to tell is, if you don't pay attention to detail, so even smallest things can lead to biggest disasters. Smallest mistake also. Here, what they did, they just did not remove tarpaulin. But that's why devil is in the detail. Pay attention to detail. If you want to join space stream, you should develop eye for detail. Nothing is minuscule. Every small detail has got its own importance for the success or failure of mission. That kind of attitude you have to develop. Then what is special about space systems? So many things are there. So special characteristics of space systems is unattended operation. Unlike your car or something which every few kilometers after you buy, within 1 month you go for service, 2 months you will go, 3 months again, after 6 months, after 1 year, engine oil will be changed. So all this kind of maintenance is there. And even houses, you take the doors. If you have constructed a new house, you will know after 6 months or something, your door will not latch, will not close properly, or bathroom the latch will not come. Like that will happen. Then again, you call carpenter, he will do some fitting, small changes. So like that, in a space, this kind of luxury is not there. You have to be there on your own for 15 years. The spacecraft has to work. That too with systems with a 68 nms kind of angular momentum. They will be running at 5,000 rotations per minute continuously for 15 years. Some of the systems, all of them have to work. And second is multidisciplinary product. I Some people will ask which branch I have to take to join. There is nothing like only aerospace. You take any branch in any college, it will have some kind of application in space systems. And work environment of space, I will tell, low volume production, mostly handcrafted single unit. Unlike see Chandrayaan, how many years it took? Aditya took 7 8 years to build. How many units are made? One unit. Recently, America launched the James Webb Space Telescope. You know how much time it took from concept to completion? 40 years. So, how do you keep the whole system working? So many project directors would have changed. So many teams, whoever originally thought would have changed. So, what is the kind of systems that should be there to keep a system work going on continuously on that? And single unit when you are doing it is very, very difficult. Not always, of course. Like launch vehicles, if you take that may be done in up to 100, 200, like that max. Before that, it will be phased out. And volume, mass, and power constraints. This is another issue. You are not able to put whatever you want, you cannot fly. Okay. So that is another thing. And high cost. Okay. And major components I have already explained. So I'll just tell from reliability point of view what is the difference between launch vehicle and a spacecraft. Launch vehicle is nothing but a rocket. Launch vehicle is a single shot mission. It is a do or die kind of mission. Whereas spacecraft is a long life mission, 6 to 15 years it has to work. Chandrayaan, you leave it because it's a different kind of mission. So 14 days it was there. But that also will be extended. Next when we go, it may go to 1 or 2 years. So that is one thing. Then environment, we talked. Testability. See, launch vehicle, you can test the final solid engine, no? Solid engine like a matchstick. Okay. So when you buy a matchbox, can you test it? The moment you burn, it is over. It may burn, it may not burn. Correct? So only at unit level you can do some small test, but integrated test of the launch vehicle is at launch pad only. And majority of systems cannot be tested prior to launch. Whereas spacecraft system level tests are possible to good extent, but there are some difficulties. I will not go in too much into technical detail. Maneuverability. See, I told the control center is there. You know, the only one control that launch vehicle commander has got is to destruct. If he is launching from shore, if it is not going towards sea as per the original path, suppose it is traveling towards Chennai, he has to destruct it because life loss will be there. So that's why he has only one button. If it is going into safety zone where people are dense or some other commercial assets are there, then he has to destroy. Kill my baby is the command, correct? He has to destroy. That is the only command available for launch vehicle. Rest all it has to take care on its own. The failure, even if it is there in one system, it has to identify itself, failure detection, isolation, and switching over. All these things have to be done by the launch vehicle by itself. Whereas spacecraft is okay, unattended only, but still limited ground intervention possible because spacecraft is continuously available. If you have redundant systems, you can switch off, switch on. Some things we can do. And I talked so much about the environment so many times. I have told. So there is a weightlessness, there is vacuum, there is temperature, there is radiation, micrometeors, magnetic field, dynamic environment. All these things are there. When you talk of temperature, the solar panels of solar spacecraft will see minus 100 degrees and plus 100 degrees centigrade. You have to design systems to withstand this. Otherwise, you have to create a very good thermal system. Actually, space, if you take by itself, is at 4 degree Kelvin, that is minus 269 degrees centigrade. Okay. And sun, when it is directly impinging on spacecraft, it can goes to plus 100. So how do you manage this? You have to do a very good thermal design so that the inside electronics packages and all are there within a band of say 0 to 50 degrees or whatever kind of designs. Let's say MBA, weightlessness, vacuum, all the environments have their own impact. So it is the study of space environment itself can be a subject for those of you interested, or how to ruggedize against weightlessness, how to ruggedize against vacuum, how to ruggedize against temperature or thermal engineering. Like that, this environment is posing so many challenges. The solutions can be found by engineers who are joined and scientists, whoever is working on this particular area. So this is one area of work, okay, like that. Again, I'll go to one another attribute that you have to do is, actually they will tell first time right, zero defect. These are all some quality terminology nowadays. I'll tell a very very simple example. We had one program director called Mr. Katti, who was his PA was there, JP. He looks always some confusing like that. We used to wonder how Katti sir is keeping him wherever he goes. He became division head to group director to project to program director. Everywhere he keeps the JP only as his PA. We were wondering what is so special about JP. Katti sir will not leave him. But when we went to Kuru, I had to at that time so many PCs all were not there. All of us together given one PC or two for area space, and JP was managing. So I had to type one note. So I requested him to type and give me. So he did it. I thought typewriter something. I don't remember. It was some 30 years back maybe. So at that time, when he typed and gave me, I saw it was beautiful. Actually, there was no mistake except for one error. Okay, so then I thought that's why JP sir, KT sir, Katti sir is keeping him. Then I went and told JP, you have done good job. Oh, thank you. He told, except that one mistake is mistake. I have done a mistake. You show me, like that. He told. I have shown him the mistake. Then he told, no. You give me the draft which you have written. Okay. Then I told I have thrown it. Then he went, searched all the dustbins, found out the draft which I have given to him. Okay, from dustbin he took out, and he showed me. You see, you have given this word wrong. Okay, that is a technical word. So what I am trying to tell you here is this kind of urge to do whatever I do has to be zero defect, and whatever I do first time itself I have to do right. This kind of spirit should be there. Not that it always happens, because you are doing R&D, things can go wrong. That is different. But whatever you can from effort side, there should never be shortcoming. So this is where I feel the zero defects and first time right. This kind of attitude you should be having if you want to enter space sector, because mistakes are extremely costly. So now I'll come to what are all the opportunities for people. So when I talk about, I'll take example of satellite, but it is almost applicable for launch vehicle also, except that in launch vehicle, chemical, that is the propulsion engineering also, satellite also it is there to a smaller scale, but in rockets, the pyrotechnics, then the propulsion, they are all on a huge scale. Structures and all are big. Satellite is small. That is the difference. Otherwise, all the things can apply. So as I have told, the payload for the launch vehicle payload is satellite itself. For the satellite, the payload is it could be a camera, or it could be a communication transponder, and it is a power systems will be there. Power systems, when you are talking solar panel, battery, and power electronics. Okay, because it has to take power from solar panel, condition, charge the battery, discharge the battery, maintain the power voltages, distribute the power whatever is generated to various electronic systems. All this will be done by power system, and then interfaces with the launch vehicle, all that. Then stabilization and control, because your camera has to point towards earth. Okay, or the communication transponder antenna has to point towards earth, or if it is Chandrayaan mission, it has to look towards Chandra, or if it is Aditya, it has to look towards the sun. If you are sending some star related, suppose some astrosat was there, it was studying stars, or James Webb Space Telescope. Again, I will tell. So if you take, it was doing a study of galaxies. So you should be able to point and pinpoint accuracy to the level of one arc second. That kind of accuracy you should be able to maintain the platform. So for that, control system will be there, sensors will be there. Okay, sensors means electro-optical. We have some sensors, earth sensors, star sensors, like that. Different sensors are there. Using them, you get the data and control system. Then actuators, because this is sensing and control is one part. But if you know the control loop, classical actuator, the wheels which they will turn and maintain the spacecraft orientation, the gyros, okay, or the thrusters, if it is chemical means, all these things will be coming under platform stabilization and control. Then mechanically, because it is like a control system is like brain. If you take human body as example, our skeleton is the structure system. That will give you support to all the other systems, correct? So same way, spacecraft also, all the packages have to be mounted. They have to be given the required orientation. Launch when it is happening, that load the spacecraft has to withstand. All these things will happen from structures point of view. So structural engineering is very, very important. When you talk of structures, one is the analysis, all those things. But even right from material selection, because we want to make it lightweight. Earlier it was aluminum. Now everywhere composites have come in a big way. So composites. So like that, lightweighting, how to do it, honeycomb structures, all these things will come under structures. Then thermal, as I told, minus 273 is space. Sun is directly heating to 100, 150. So how do you maintain balance between these two and keep the spacecraft some kind of air conditioning, though it is between 0 to 50? So how to do that? That is all thermal engineering will do. Then mechanisms. As you know, solar panels cannot be going like a deployed configuration. Launch vehicle you cannot keep like that. You have to contain everything within the top of that. India heat shield is there, no? Within that you have to put. So afterwards it has to deploy in the deep space when temperatures are so low. The systems have to deploy and then work. Same way communication antenna, they are huge. Some of the antennas we have done are 6 meters in diameter, what India has done. Outside they have got 18 to 24 meters kind of diameter antenna. So whole thing is folded to less than half meter when on ground. Once it goes into space, it has to deploy and take a shape of 24 meters or 18 meters kind of dish. How does it happen? That is all the where mechanisms are having a role. So mechanisms is another system. Then propulsion, of course, because that is the fuel, no? Whatever we eat, drink, everything, you have to need energy. So the chemical energy is provided by the propulsion. Then various subsystems are made. Communication systems are there. Okay, I think some of it missed here. Otherwise, communications are there. So that is telemetry. What how the satellite is doing, some data will come. You want to control satellite, so some tele commands from here will send commands. Then the data itself. If you are having a camera, that data, video data, audio data, whatever you are doing, all has to come to ground in gigabits per second kind of rates. So how do you bring it down? So there is a modulation, demodulation, then antennas. All this will form part and digital systems, coding, encoding, okay. Then compression because you want to reduce the data compression. All these kinds of things will come under communication systems. So like this, various subsystems have to be brought together, assembled, integrated, and tested. That comes under assembly, integration, and testing. And there is a mission altogether. See, Chandrayaan has to be launched on a particular day only, or in these 3 months only it can launch. Aditya, had we not launched in the last that week, it would have gone to next launch is in January only. Or they are telling that today night lunar insertion is there. TLI, you would have heard. Now everybody knows. So why it has to be on that day only? Because of whatever sun, moon, geometry, all those things. All this who will do? That is called mission planning. Then satellite itself has to be maintained 15 years. So how to do? Which orbit to go? Okay, where we have to keep? How to plan? Now Lagrangian point, everyone is telling. Who has to decide that we have to go to Lagrangian point? All those things will come under mission. So here lot of mathematics, orbital dynamics, okay, and so many specific tools are there, satellite toolkit like that STK. So those familiarity and learning expertise, all those things will be required in the mission area. What I am trying to tell you is, while explaining satellite areas, it will also let you know what are all the fields where there is a scope, and if you join, where you can work. Then spacecraft architecture, I think I have covered all of them. Okay. Data handling, power, communication, control. We call two things. One is payload, I have told, which realizes the service, and other things are platform systems. That is like a like bus we call. See, in a bus when you are going, the main engine, the structure, whatever is there, tires, all those things are part of the bus, correct? So like that, it is called bus system, which takes the payload, that is the passengers, to their destination. That is the payload system. So now I'll tell about the carrier in ISRO. Okay. So first I'll talk about ISRO. Space is not just ISRO alone. Anyway, there are various admission streams. Of course, IIST is Indian Institute of Science and Technology, which is there in Thiruvananthapuram. Here, the admission into BTech is based on JEE main. All of you must be knowing. And for MTech, I think there are advertisements will come and one can see and apply. And PhD also people can pursue. Both the people within ISRO outside, they can all approach. But for recruitment into ISRO, there is something called ISRO Centralized Recruitment Board, ICRB, which is a combination of first there will be a written test all over India. I think these days more than 1 lakh people will be writing. In North India, especially if you go, like IIS academies, there are so many people who train for ICRB written test in various branches of engineering. So this will be there, okay, and that will be followed by an interview across India, depending on the region, somewhere to different places like Hyderabad, Chennai, Bangalore, or Kolkata, New Delhi, okay. So like this, at different places, they will be conducting the interview for the convenience of the people, and whoever has passed the written examination, if I remember correctly, I think they will be paid second class train fare by the ISRO board. ISRO, I think. Okay, I'm not 100% sure, but I think they are paid if they are qualified. So out of 1 lakh, this filtering will come to some thousand or less than that. And from that, whatever be the required number and the number of vacancies itself, how do they come? That is based on the ISRO internal assessment. There are various ISRO centers which I will show you. So they will be giving the requirement to the headquarters. At headquarters, whoever is responsible for the recruitment will collect centralized. They will collect. And earlier, okay, it used to be individual centers used to recruit, but as ISRO has grown, the questions and the public accountability, all those things will change. So it is made a more transparent process. So that's how you can apply through ICRB. That newspapers only you have to see and find. And for MTech, PhD people, depending on the specific posts available at a particular center, it is not, it is by advertisement, it will come most of the times that you have to see and apply. And MTech also, they will be joining in SC grade only. Only thing, next promotion to SD will be within 2 years for MTech, and BTech maybe 4 years. If it has changed a little, I don't know, because these policies will be continuously changing. But typically, MTech persons have got the advantage of getting the next promotion. Joining time both are same only. Next promotion will be little faster for MTech because they have studied 2 more years, no. So naturally, that consideration has to be given. And for a PhD people, the number of opportunities are less, but wherever it is there, they will become SD directly. So SC to SD normally it takes 2 years for MTech, or so whatever time they have spent in doing their thesis work, so that PhD. So that's why they will be joining as SD directly. And lateral recruitment, that is from some DRDO or some other organizations if you want, but it is very very rare. Somewhere from NASA, if chairman has found someone useful, if he requests, if they come, very very rare, but generally it's not an option, but it will be there if it is really required. And then diploma in non-engineering degrees for BSc people and all. MSc is equivalent to BTech only, like that it is treated. ICRP, I think MSc people also can apply. But for other things, BSc and all, there are scientific assistants and technical assistants. So diploma, that is what whoever have done LME, LCE, LEC, like that, they are there, no diploma courses in engineering. So they are all can go for the scientific assistants. They will be coming through some advertisements and maybe still lower like tradesmen and all if you go through employment exchanges of respective states or something like that is there. Okay, then after joining, okay, this is about how to get admitted. And after joining also, I want to just tell what are the prospects that you are having. Your center where you will be placed, I think I'll go and come back. That is better. If you see space centers and in units in India, the major ones are, of course, Sriharikota is there nearby Chennai, where the launch will be happening. Bangalore is there, where Space Commission and headquarters are there in Bangalore. Apart from that, we are having the satellite center. Now it is called URO Satellite Center. That is the key thing where, and control centers, ISTRAC, and even Chandrayaan and all the control happens from one Bailalu, that is also nearby Bangalore only. And yeah, like that MCF where all geosynchronous satellites are controlled. Ahmedabad is there where The satellite communication and camera payloads, they are all done in Ahmedabad. VSSC, major work of launch vehicle is done at VSSC. Launching is from here, whatever, Sriharikota, but most of the design, development, all of those things are done from. I am telling big centers, okay. And same way, NRSC Hyderabad, National Remote Sensing Center. So what they are doing is basically get the data from the spacecrafts, okay, remote sensing spacecrafts, try to analyze them, give it to the user ministries or whoever wants it on a demand basis. So all that is done at NRSC. Then there are national natural resource management systems, NNRMS laboratories, all around India. They are there, you can see. Okay, you can go to ISRO website also, you will be knowing. So there and all the applications and all, but that will be a smaller scale. But heavy engineering wise and all, if you take Bangalore, Trivandrum, then Ahmedabad, okay, and NRSC to some extent, they are there, okay. And within Trivandrum, there are a lot of centers. Liquid Propulsion Center is separate, Vikram Sarabhai Space Center is different, okay. And IISU, ISRO Inertial Systems Unit, where wheels and all those systems are made. So this is all what happens at. Now I'll go back. So where you will be placed in ICRB, I don't think you will have much options. Whatever because it's a need-based recruitment, so you have to go to the place wherever you are posted. You cannot say that I don't want this and all. Maybe at the time of, you may have an option to indicate your place of choice, but it is not guaranteed that you will get the place of your choice. Then career progression, how you go in promotions up to engineer SG, SC you are joining, SC to SD, SD to SE, SE to SF, SF to SG, up till that departmental promotion committee. Depend, there will be, it's a merit based, not vacancy based. Other places, many government, only if a post of senior manager is vacant, like in a bank, only then the test will be, that post will be filled. But in ISRO, up to SG, it is purely based on merit. If you go and pass in that departmental promotion committee, that is interview basically. But in the interview committee, there will be members from within ISRO and outside also, two external experts will be there, and internal also experts from other centers will be there. That is to have transparency. And like that, so you can go up to SG. Beyond SG, it is based on the recommendations of the your reporting authorities. Okay, that is one. Then transfer policy. Okay, you are, as I told, your recruitment may not be always at the place of your choice, but there is a scope for transfer, but it is not a right, and it is request based. And if it is a mutual, suppose somebody wants to come from Ahmedabad to Bangalore, somebody wants to go from Bangalore to Ahmedabad, and if their area of work matches, otherwise one mechanical engineer coming there to here and electrical engineer going from here, it may or may not work. So it is a mutual, but that will be very few. Our husband and wife both are in ISRO, one of them is in Ahmedabad, one of them in Trivandrum. Those kind of considerations are, or in extreme cases, very severe, though the transfer things are there, but it is not a routine. Generally, transfers are not encouraged, but where very well deserving cases, there is always scope. Okay. Then there is a pursuit of higher education. You will have a lot of scope after some number of years, 2 or 3 years. You can, if you are BTech, you can go for MTech. If you are MTech, you can try to study in PhD. And some of them are even sponsored by ISRO, except that in that case, you may have to give some kind of bond that you will be there, or you will be you have to pay back, no, because they have spent on you, so some commitment will be there. Otherwise, you yourself also can go. Earlier evening colleges, they used to be there, but nowadays I think overall also evening colleges also have come down. But otherwise, you can always, there is a scope for studying to go to higher education and come back. Okay. And in between a leave you can apply. Okay, sometimes you may have to apply loss of pay leave also, that is okay. Hmm, like that. So pursuit of higher education for BTech to MTech, or MTech fellows for PhD, like that, the scope is there, and lot of people have done their studies after joining ISRO also. And internal recognitions, there are a lot of schemes and internal awards nowadays. Okay, this government has slightly changed the internal award schemes and all, but still it is possible that there are various methods of recognitions. Of course, that is not everything. Nobody should work for an award, but just I am telling the. And external recognition. Sometimes there are so many professional bodies, so they would like to give award. So they will write to ISRO to suggest some names. So like that, those things and all are also possible. And ample opportunities to pursue non-technical interests. I'll show you a slide. And work-life balance, yes, it will be difficult. Okay, though we try our best to maintain that, but a launch, Chandrayaan launch was at what time in the night? At that time, whatever, one's son may be sick or one's wife may have to go somewhere. If you are the key architect in that particular program, you cannot leave the desk and go, because you have been trained, or the systems are yours. And without you, that launch, whole country is waiting for you. Okay, like an army man only, you take, suppose he cannot tell that at the time when border is calling, they cannot tell that my house I have a problem. Except extreme emergencies are different. There is always human angle, not that people will, but in general. So to that extent, your work-life balance can suffer, and you have to put extra hours. No, so that is another thing. See, Chandrayaan, we were seeing even after successful launch, all clapped and went. The people were working for next 1 or 2 days continuously, because you have to maintain the spacecraft. Of course, shifts will be there, all that, but some key people will have to be there. So that is another aspect. And the field of work, just this actually I have prepared for my people who used to join ISRO, but for you also I can tell, because you are all going to pass out. Wherever you go, actually these things apply. Most youngsters want to work in design or analysis, but the organization wherever you are going, there will be different fields of work: design, analysis, fabrication, test and evaluation, product assurance. Facilities will be there to maintain, project management, program planning. All functions are equally important to realize center's objectives. Initially, you may feel peer pressure, because when I joined, also people told you joined quality, ayo, papa, like that. People will talk, but you need not worry about that. And in the long run, it really doesn't matter. I have seen ISRO leaders coming from anywhere. There are product assurance people who have become center directors. There are mission people who have become center directors. Okay, there are design people who have become center directors, and there are analysis people who have become center directors. Anything is possible. What is required is you have to do good work and innovate. Good work is always recognized and appreciated. It gives you a sense of fulfillment. What is needed is sense of belonging. You have to feel it is mine, and urge to excel, new ideas, dedicated efforts. These are the things. And documentation, this is one more thing I want to tell you, because systems have to, I told James Webb Telescope for 40 years they have been working. How do you transfer that? So documentation is very, very important, and people generally get bored. Even your own project reports, I know many people will do the work, but when it has to be documented, they will try to see somebody will give somewhere, can we pay and get it done, like that kind of thing. So there are various types of documents. So actually, for me also, so initially I was, at that time, one person told me, Prakash, the only thing that remains on ground once the spacecraft goes into orbit is the document. So anything you want to reconstruct, anything, so documentation, those skills also you have to develop. And general one question people will ask, what it is like being in a ISRO, ISAC ISRO culture. Yes, here we can do it spirit and celebrate each other's success. It's not that we are selfish or anything. Rise to the occasion. In ISRO, I have not heard anybody who says when boss gives some work, it is not possible, though he knows it may not be possible. First, you rise to the occasion, study, and then tell why it is. And not deterred by setbacks, failures, of course. This is very well known. All of you know. Chandra, I will show. Okay. Openness, receptiveness to new ideas, and no hierarchy in technical assessments. A person who joined today can ask a question to chairman, okay, in a review. And very good review system we are having, committee mode of working, teamwork, personal sacrifice, and that's where family support is vital, and harnessing of very talented base. And we are a family. That kind of feeling is what makes ISRO unique among several government organizations. I am not saying ISRO is the only government organization working. I know there are so many departments which are unsung heroes. ISRO, at least we have this glamour. But without that also, even in our childhood, a postman used to, even today, in some villages and all, he will travel all the way. He will go come to the house and deliver the postcard. So railways, you take like that. There are so many departments. Agriculture, India has become self-sufficient in agriculture. It is because of our agricultural scientists. Okay, only people may not be knowing about it, but the amount of work that is done in the field of, so everywhere there are so many good work happening. I am talking because you are interested in space, what it is like being in ISRO. It doesn't mean that only ISRO we have a good culture. Every organization will have its own culture. And I just told how about your personal, if you have some interest, there are so many various technical, cultural, literary events in our ISRO Satellite Center. There is a technology day for youngsters, a science day for school students we organize. There are so many professional associations, ISAC Welfare Association, where they do all the ballet dance and all that in the afternoon in the auditorium, and evening go back and take X-ray of some particular component. So both are coexist. And Hindi Divas we do, Rajyotsava we do, Karnataka Rajyotsava here. So Grand Slam, we organize cricket and all Grand Slam. Sports events are there, so many sports, chess, all those things. Even retirement functions used to be so special. Photograph club was there, trekking club, amateur radio club. So seeing all this, you may be wondering what these people do. Otherwise, I just want to remind, we also make satellites. Okay, like Tata Steel, they said we also make steel. Like today's mobile, apart from phone calls, we do everything with the mobile, no? Like that. So transition, the one more thing, because you are going to go from student phase to the what I have called is transition from classroom to clean room, because satellites are assembled in clean room. But same way, even if you go elsewhere also, you have to remember, I think for youngsters, I want to give this advice. You are becoming dependent to independent. From the day you step into your new organization, you are going to be independent. And receive to transmit. All these days, your teachers were teaching you. Now you have to give something back. Knowledge gap, the moment you enter, because people there are so much they are there for years, no, so I don't know anything, that kind of feeling you may get, that you should overcome, because you will also learn as you go. And theory to practice, especially in our education system, we focus more on the theory, but here you have to practically do the things. Teacher versus boss, whatever teacher you may scold, you actually you may mock at them and all, still no teacher will want his student to suffer. So that is the beauty of teacher-student relationship. Day before yesterday only we celebrated Teachers' Day also. But boss can be different. Yes, all of you have watched that Three Idiots movie. So boss is boss. No? That's why they say. So when you are dealing with a boss, it's different from dealing with a teacher. So that is another transition you have to know how to handle it. Because boss has some expectations. Teacher, when he does, if you listen or not listen, who is going to lose? Only you are going to gain or lose. If you follow your teacher, you will gain. If you don't follow, you will lose. Nothing will happen to your college. Out of 10,000 students, one student doesn't listen to, it doesn't matter. But in the office, your actions will result the future of the organization, the success of the organization. So that is where the transition is main. Friends versus colleagues. There is a lot of difference between having good friends and having a good colleague. Your colleagues will be all ages, 60-year person also will be with you. And friends. Self versus organization. All along you are working for self so far as student. But when you come here, you are becoming a part of an organization. Anarchy to hierarchy. Colleges, you can do anything. Whenever power goes, we all used to shout, oh, and come out of hostels. But office, it is a hierarchical system. Hostels versus quarters. Okay, hostels, you know what all you would have done, jumped the walls or whatever. Quarters, or if you are suppose placed in your quarters, it's different discipline. Other families are there. Okay, it's different. And records to results. All of you, at some stage or the other, at least we used to see. As generally record writing, nobody wants to do. They will take one person will do, all will copy. Now things would have changed. Okay, but here you are judged by your results, not just producing the records. I just thought this slide is important for you people, because when you join work, it's not need not be space alone. Wherever you go, please keep things in mind, so that your confusion will be less. And other needs you aspects which you have to develop to join any organization will be communication skills. This is somehow this WhatsApp and social media has killed the written skills and oral communication skills. They are coming down, but it is very very important, oral and written communication skills in a formal way. And listening is a very very important thing. People will be very impatient. I always want, like now I am doing, I want you to listen, but when you want to ask something, I may not be patient to listen. So listening is another important skill, and presentation skills. See, you may later complain, I am not getting recognized for my work and all. Unless you present what you have done properly, how do you be recognized? So the presentation skills, accordingly the tools that you have to use, statistical tools, physical health, this is also most important aspect. If you are unhealthy, whatever you have, all the skills, how long you can sustain? And emotional maturity, this I have told, I think I'll not go, but it's very important not to get depressed. Okay, depression is another aspect which is driving the youth nowadays, or really killing the youth. So that you have to develop maturity and perseverance. You should not get deterred by failures. And general aspects, some people, they are ready to help, but they don't want to take help. They feel it's a very shame, nothing like that. And some people want to take all the help, but they don't want to help others. Both are wrong. You have to help, and you have to seek help when needed. Password security is one very important. Whichever organization you join, it is very important that you maintain your password security, because you are liable for whatever happens in your mail account or your WhatsApp account or Facebook account, anywhere. You cannot tell later that it is tapped. You just assume that somebody gets access to your phone and sends some kind of inappropriate message. I am telling from experience as a group director. Very very innocent ladies, they were really tortured, you can tell, because they were, somebody will use your password, then it is becomes a security agencies do not worry. For them everybody is a suspect till proven not guilty. Okay, so your use of net, okay, this is another thing all of you should know, that in the office is monitored. Never use office net for any of the personal use. And be adventurous, fine, but take care of safety, like bungee jump and all. And this is actually meant for our new entrants, but for you also it applies. And never criticize your office in public. This is one thing you have to. You may feel great even in your own house with your own parents or whatever it is. You should never criticize your office. That much you have to absorb, like Shiva, Lord Shiva, Garadakanta, no? How much poison he could keep in his throat. He has never allowed it to come out. Correct. So that is what you have to develop. And do not generalize without sufficient data. People will tell, oh, these people are, that is all not correct. You have to really study before coming to conclusions. Keep good company, choose right role model. We are accountable. So public money, especially in government organizations, there will be audits. That is a public money, and integrity. All those things are important. Social justice. This is another important thing. Any one comment, if you make without your knowledge, if it is picked up, you would have seen how many politicians and all would have suffered, especially with respect to gender, with respect to caste, or with respect to some groups which were not fortunate enough in their earlier generations. So all those things, law protects them. Constitution protects the all these sections. So you have to be very very cautious. Even one unexpected or unintended remark also can lead you to a lot of trouble. So you have to be very matured in and careful in the use of social media. I have told punctuality. This is one thing I want to tell, especially ISRO or anywhere. Today, many people started joining after 10 minutes also. I joined 10 minutes before. I'm not saying anything, but just this is another trait as India, as a community, we have to develop, not just students or anything. See, Chandrayaan launch, if you delay by 10 minutes, can you launch that day? You cannot. We do things to microseconds, milliseconds kind of accuracy. So at least if you want to join space sector, any sector, it's correct. But if you want to join space sector, try to become punctual from tomorrow onwards or tonight onwards. And from a new entrant, they want to work in, okay, this I have, I think I'll skip. The way I told you, expect, boss also expects something from you. That is the professionalism, initiative, responsibility, resourcefulness, loyalty, ability to work as a team member. If you alone on Einstein, it doesn't matter. Finally, you have to work with your team members, solutions rather than problems. Bosses can forgive mistakes, but if you lie, you are gone. So trust deficit will come. Never lie to your boss. Why you have come late? You tell I got up late. That is okay. Don't tell that by what is that, traffic jam and all. Okay, it can always be one day or the other you will be caught. And once you are caught, the trust is gone forever. Okay, so this is very important. Be honest and be truthful. Okay, time is running out. Otherwise, I had a good example, but will not tell. But you have to suppose, even after joining this, to suppose you have done something, some instead of plus 5 volts, you have given minus 5 volts. You have to report it. You cannot be afraid that what will happen if I tell. Okay, so that is very important. Otherwise, the astronaut's life may be lost. if you are not telling truth. Okay, it is possible, no? So that is very important to be truthful. And Vidya Balan in Dirty Picture says, फिल्म की सक्सेस सिर्फ तीन चीज से होती है, एंटरटेनमेंट, एंटरटेनमेंट एंड एंटरटेनमेंट. I will tell with all my experience, a project's success happens only due to three things: interface, interface, and interface. My wife is an angel to me. My mother is a goddess to me. Problem comes when you bring angel and inter goddess together, correct? So when you have to deal with the technical interfaces, I have so many examples. I'm not explaining more, but personal interfaces also. Like I told, see, you may join an organization where your boss is 2 years younger to you, and your colleague, your subordinate may be 10 years elder to you. You should be able to work with both of them. So this kind of human engineering skills you have to learn. So this year I told you have to see, you can see the person in pink shirt, Somnath. He is the chairman of ISRO now. This is long, long back when of the launch vehicles failed. This is the scene in ISRO's control center. Do you think people have at that time feeling bad is normal? Do you think people rested? No. So forget what hurt you, but never forget what it taught you. Then work for the next mission. Chandrayaan 2 failed. People worked. Chandrayaan 3, not a full failure. I'm telling landing portion. So you will get this moment also. But in between, the most important requirement is not to get bogged down by failures in your personal life also. Be You should develop that resilience. And reviews is one important thing. I wanted to tell something, but lack of time, we started late, so I'll skip this. But and one more important is, I am only sleeping. Enjoy your work, whatever be the situation. This was in Kuru. I had to drive through some forest because some strike was there. Then night, I am not going to detail, but whatever be the thing, you should be able to enjoy and catch your sleep. If you always do what you always did, you will always get what you always got. This is an old saying. So now the changing government also has realized that. And now here, this is an important slide. Globally also, the earlier space initiatives were governed by governments. Now emergence of new space has come, which innovative technologies, entrepreneur Elon Musk, whole world knows him. New models for R&D, commercialization, financing frontiers are there. So shift in control in space activities from national activity to entrepreneurial activity, it is becoming. Same way, Indian government also has done a lot of things like a new space policy, opening up if ISRO facilities to any private entrepreneur who wants to do something and to use the ISRO facilities for test, they can save some nominal fees and use. So the bodies are also formed like that. ISRO has to future will focus on research and development, whereas NCL will be doing the aggregator function, and in space will be promoting the private sector. The idea is, out of $350 billion space economy across the world, right now India share is 2%. How to take it to higher levels within next decade or whatever it is. So with this, these changes are happening. So the key thing I am trying to tell you is, don't look, if you want to space, don't think ISRO is the only thing. The slowly the number of opportunities in ISRO also may come down because production is shifting. What can be produced outside should not be done in ISRO is the government's mandate now. That is the new space policy says that. So the opportunities for PSLV hundreds have to be made SSLV now successful. Tomorrow 100 SSLV demand will come. They will not be produced in ISRO. They will be outside. Some consortium like L&T or somebody may do. I am not giving full list of companies, but Venkatagiri is working on that. You can talk to him. So there is a lot of things happening in private space, and in future number of jobs and all will be as it grows. As on today, it may not be so, but as it grows, the opportunities in private space sector also you have to be keeping in mind. So though we have come a long way, we still believe space will not forgive you if you make mistakes. Even life will not forgive us if we make mistakes. So I'll end with one rhyme. Oh mummy, please give me some vegetable soap to make me grow strong from my head to my toe. C for carrot, B for beetroot, T for tomato, to make me grow strong from my head to my toe. P for peas, B for beans, P for potato, to cook them all together and make me some soup. Make it yummy, make it tasty, make it delicious too. I will drink it up all to the very last drop. You may be wondering what space opportunities and all. Here I will tell. Here there is a supplier, that is the mummy. There is a customer, the boy. There is a product, the vegetable soup. It has got some functional specifications: yummy, tasty, and delicious. And there is a goal what for it is being made to grow, to make me grow strong from my head to my toe. Like that every organization has got a goal. And other things, okay, I have no time, I will not explain, but there are some disciplines you cannot put brinjal and do. There is something called qualified parts list, there is something called declared material list, declared process. All these things have to be done, and then only theoretically the life of a spacecraft is decided by the amount of fuel that is there. Once the last drop of fuel is there, you cannot be controlling the spacecraft, you will not be able to control, and it will die. So till last drop of spacecraft is there, we do not want our spacecraft to lose. That needs a very good workforce who are committed to their cause, okay, and who are ready to help the organization and themselves. So I wish you all to have a very good career in the space sector. I am not just saying ISRO, and some of you may pursue outside space also, doesn't matter. But this customer, supplier, product, this equation remains same, and the commitment from each individual to their organization is what drives an organization, and organization has to be committed to its customer. So with this, I will be ending. Sorry, I took because we started late. I would run, but I hope I have covered many of the questions. Anyway, I hand it over to the organizers.
Thank you, sir. Thanks a lot of your really fantastic presentation. I hope our students get lot of informations. Dear students, are requested to make the best use of the program and ask the questions to our esteemed speaker.
Actually, I wanted to go just beyond telling that this job is there, this job is there.
Yes, yes,
Isn't
yes,
it?
already,
Yeah,
sir.
that was my.
Just a few minutes, Mr. Maniraj. Please interact with the students with a few words. Mr. Maniraj, sir, please close your share screen, sir. Yeah, thank you, sir. Maniraj, please unmute and interact with the students. Few words.
Thank you. Hello, sir.
Yeah, students.
Good evening, sir.
Some echo is coming. Can someone
Yes,
closer to the mic tell the ask the question? Repeat
yes.
the question to me.
Pavitra is asking the questions, I think.
Yeah, yeah.
Yeah.
Yes, Pavitra, please go ahead. Sorry, we are not listening.
Namaskar.
Are you able to listen? Adi?
Yes, sir. Yes, sir.
You are able to listen to question? Her question?
No, sir. No, sir.
That's fine.
Okay. Anyway, sir. Anyway, we will collect the
What I will
questions
do,
from
my
students.
email is there. If anybody
Yes,
has a
yes.
specific query, they can always, or to Venkatagiri, you please give the questions. I will
Yeah,
answer.
yeah. Yeah,
That is
sir.
better because we have come through him. You ask
Hmm.
Venkatagiri so that
Okay.
I can give answers to him and he will transmit to you.
Sure, sure. Definitely, we will cut the questions from students and we will email to you, sir. Then we will interact with our students.
Yeah.
Thank you. Mr. Ramesh Kannan. Mr. Ramesh Kannan. Projector. Okay, okay, okay. What of thanks? Okay. So, okay. Sir, really fantastic presentation. Your presentation is very fantastic. And we
Thank
got
you.
lot of information. I hope our students get lot of information and clarify the doubts. Hello, sir.
Yeah.
Thank you, sir. Yeah, thank you, sir. Thanks for your presentation and valuable information, sir. Yeah,
Okay.
sir.
Thank you.
Definitely. Yeah, we will meet one more sessions. Will future with the few
Yes.
details. Another new information, sir.
Yeah, I have gone little beyond space also because youngsters
Hmm.
know they need a lot of, especially when
Okay,
they
okay.
join, when they leave college and join a new place. a lot of uncertainty will be there in the minds. So
Okay,
I
okay,
addressed
okay.
some of those aspects. Okay. Okay.
Thank
Thank you.
Thank you, sir. Just
Thank you. Shall I leave?
just a minute, just a minute. Thank you, sir.
Okay.
Thank you. Thank
Thank you.
you
Thank
very
you.
much, sir.
Nice.
Thank you, students. Thank you, Maniraj and Ramesh Kannan. Thanks for your cooperation and thanks to all students. Thank you.
Thank you.